9.2. 9.2. We're talking about the binomial theorem. Alright, so the binomial theorem, what we did before was we used Pascal's triangle. Right? The Christmas tree, as you guys put it. Today, however, we are going to use combinations. Alright? Instead, to find our coefficients. So the first thing I want to say to you is the shortcut to the notation, sometimes we write it as in parentheses as n over r. If you see this notation, what this notation means is NCR. Okay? Alright. Now, the other thing, if you recall, what I had you do back in Algebra 2 is we listed all of our coefficients. We started with the first term in the binomial. We listed it counting down exponents. Right? And then the second term in the binomial, we started at the bottom and counted up. Had you multiply everything across? You recall all that wonderful stuff? The list going down. Some of them ended up really, really big. Alright, so what we're going to do today, though, is we're going to change it up a little bit. The way it's going to work is whatever your exponent is on the outside of the binomial. So let's say I have, we're going to go a plus b to the n, okay? N represents the total number of terms we're going to have, right? Actually, it's going to be one more than that. So it's what we're multiplying by. I guess so.
When you come out of the west morning, I mean, I could have switched it earlier, I just straight west morning. That really don't feel like it's west. I know it's cold, but it's coming out of the west.
Alright. So, the way this works is you are going to start with your first one. Now, do you like this notation or this notation better? The right one? Okay. So, in the first spot, you're going to start with N, C, and then 0. You're going to take the first term. In this case is A to the N. The second term is going to be B to the 0. Okay? So whatever this R is where B starts at. Alright? It's going to be okay, just trust me. Plus. Then we're going to do NC1. Now, A is going to go down 1, and B is going to go up 1. Plus.
Okay. This is a long one. I gotta try and figure like
N minus 1.
Yeah, N minus 1 on A. So A is going to start with the total number to begin with, and it's going to count down. B is going to start at 0 and count up. You guys are going to be alright. Okay, so then we'll do like NC2. That means A will be to the N minus 2, and B would be to the 2. Plus, and this would continue until we ran out of our exponent. Okay? So, let's try a very short one to begin with. Okay? So, we are going to multiply out. Let's do x plus 2 to the third. Okay? Alright, so what it starts with, the first term, the 3 is what it is, right? So we're going to have 3, choose 0. The first term is the x to the third. The second term is my 2 to the 0. See how the numbers at the bottom, the n and the r, you'll see n and the r on top, right? Plus. The next one will be 3, choose 1. X to the second, 2 to the first. Is that good? Plus 3, choose 2. X to the first, 2 to the second. Plus, this out of my way. The last one would be 3, choose 3. X to the 0, 2 to the third. Alright, now we simplify.
Oh, Lilith,
What?
just slow down for a minute, so I try and comprehend all of this. How many copies of them? And then we can... Alright, I got the code.
Okay. So for some people, they like to change this 3C0 into a number to begin with.
So,
What?
so is the number on the outside gets bigger and you're reaching and then keep going on? That's a lot of work.
So if this happens to be to the 12th, guess what?
All the way to 12.
Alrighty? So in this first one, 3, choose 0 actually equals 1. And then I have x to the third times by 2 to the 0, which equals 1. Thank you. Plus, this one, 3, choose 1.
2, 3.
Is 3, yes. This is 3 times by x squared times by 2. So we still have to come back and simplify this term. Plus, 3 choose 2 is also 3, x to the first times by 2 to the second, which is 4. Plus, the last one, 3 choose 3 is 1, times by x to the 0, which is 1, times by 2 to the third, which is 8. Alright, so let's go through and simplify this. We get x to the third, plus 3 times 2 is 6, x squared. Plus, here we have 3 times 4 times x, or 12x. Plus 8. Okay? It's not as bad as you think it is. It's just we use Pascal's triangle 4 to have numbers. I just want you to write it as a combination now. Okay? Alright, so let's try something. So into what the homework actually looks like. Alright, here we go to example number 1. Example 1. Similar to 1 and 3 in your homework, it just says expand the binomial. And maybe let's do a plus b to the 5th. So, okay, we're going to write it all out first, then we'll go back and simplify it. Okay? Alright, so, because it's to the 5th, remember that is your n. So we're going to start with 5, choose 0, a to the 5th, b to the 0, plus 5, choose 1.
Where did the 0 come from? Oh, no,
Okay, we're good?
yeah.
Alright, we're counting all the way to 5 now as we go through. So now a goes down 1 and b goes up 1. So those exponents should total 5 every time, right? Plus, this is now the third one, so I have 5, choose 2. It's a third term. If you look at between my n and my r, what's the difference here? It's 3. It's a third term. 3 difference in between those. So I have 5, choose 2. A goes down 1. B goes up 1. Plus. Next one is 5, choose 3. a to the second, b to the third, plus 5 choose 4, a to the first, b to the fourth, plus 5 choose 5, a to the 0, b to the fifth. So it follows a pattern, right? It's just a matter of going back and simplifying it. Okay? So 5 choose 0. And again, you can go back through here. 5 choose 0 is actually 1. If you like to go back through and change all these, 5 choose 1 is 5. I believe 5 choose 2 is 10. 5 choose 3 is also 10. 5 choose 4 is 5. And 5 choose 5 is 1. Alright, so let's write this out. We have 1, a to the fifth, b to the 0 is 1, plus 5, a to the fourth, b, plus 10, a to the third, b to the second, plus 10, a to the second, b to the third, plus 5, a, b to the fourth, plus b to the fifth. How are we doing? Okay? Alright. It's really just following a pattern. I need to get you guys into some patterns before we move on. Okay? Alright, example number 2. Why? Okay. You good? Okay. Alright, example number 2. Now, example number 2, actually, in questions 5 and 7, it tells you to expand it using Pascal's triangle. So you can do it this way or you can do it that way. It's up to you for the next 2. Totally up to you. Does anybody need me to go back over that? No? Okay. Alright, so example number 2 then. Getting down to numbers 9 through 12. It asks you to evaluate. And it gives you this. How about 12 over 4? What does that mean?
Oh,
Yeah, 12C4. So you get to grab your calculator. Type this in.
wasn't wrong, but
I can't make your life super easy, Tyler.
why?
Yeah, thank you. This equals 495. Nice job. That's all you have to do for those double problems.
What career do you take and have to use that example 1?
Probability, well, you can put that together.
Yeah, it really does work. And
Really?
yeah, wait till we get into some more problems that are similar to this. Like, not today. When we get into probability stuff, right? What's the probability that your cow is going to be female and all brown? We'll be able to figure that
You
out.
better not be all brown.
I know. But we'll be able to figure that out. Okay?
Mommy and daddy are not brown.
Alright, example number 3. On example number 3, this covers 13 through 16. It says find the coefficient of the given term so I want the coefficient for, let's do x to the 5th, y to the 8th. That's the term found in the binomial x plus y to the 13th. Alright, so all of our information is here. Now, because I'm just using variables, it really only, the only thing that affects the coefficient is the c part, right? if I had 2 in there or I had something else going on, it would change it. Alright, so if this was like a 2x or anything like that, it would change up my coefficient. So, to find my coefficient, remember this is my n. Where is my r?
Oh. X. No.
Alright, so what I want you to do is go, oops, I don't want to do it that way. Let's go ahead and put it into 13. Choose 8. What'd you get?
487.
Yes, 1287.
But don't we have difference?
Yeah. Right? But it's the idea, this is the information you're given. So you need to know out of that information, what is your n, what is your r. Okay?
Two hours going away.
It's because remember, actually let me go back a second. Let me go back to here. Yes.
So, is mine, or is the y, actually always going to be the r?
The second term, yes. Okay? So your r, this n is out here. As we're counting up, this number right here is your r value. See how it's NCR, this is r? So here, it happens to be the same exponent on the second term every time. See the r is there? The r is here. Okay? The second variable, the second whatever it is, right? Are you guys okay with that?
Yeah.
Okay. Alright, let me go back where I was. Okay, so let's move on to example number 4. On example number 4, that is 17 through 20, huh?
3.
Sure. 17 through 23. It's going to ask you to expand. That's all you're doing. You're expanding it. So, we got to get a little bit tougher though. Just because I want to put a hard one up here as our last example. Not a hard one, but what if I have something like 2x plus square root y to the 4th. Alright, so we're going to start, obviously this is our n, right? We have 4 of them. So we start with 4c0. Then we have, and I'm going to put in parentheses, 2x, because it's a term together, to the 4th power. And then the square root of y to the 0 power. Do you have to write that one down? No. But it does help you keep track of the pattern going on, right? Okay, plus 4c1. Sorry, somebody's phone's going off. 2x to the what? Good. To the 3rd, and then I have the square root of y to the 1st. Plus 4c2. 2x to the 2nd. Sorry, square root of y to the 2nd. Plus 4c3. 2x to the 1st, square root of y to the 3rd. Plus 4c4. 2x to the 0, and again, you don't have to include that one, but I am so you can see the pattern. Square root y to the 4th. So now it's up to you how you like to simplify this. So looking at the very first term, this first one right here, I'm going to circle it in yellow. Maybe I'll circle it in yellow. Maybe, there we go. This first one right here. 4c0 is 1. Okay. We have 2x to the 4th. What is that? 16. X to the 4th. And then the square root of y to the 0 is just 1, right? First term's done. That one wasn't too bad. Let's simplify this one. 4c1 is 4. 2x to the third is 8x to the third. Do you guys want us to multiply together first, or do you want me to do it in 2 steps? Just multiply right off the bat?
Yeah.
Okay. So I have 4 times 8 is 32. X to the third, square root, y. Plus. This one is 6 times 4x squared, so 24. X squared times y. Exactly. The square root of y squared is just y. Plus. This one is 4 times 2, which is 8. X. Y square root y. That's it. Tricky, huh? There's technically 3 of them, right? Plus. Last one. 4 choose 4 is 1. 2 to the x to 0 is 1. Tell me about the square root of y to the 4th. Y squared. Very good. Okay? So this term right here, I'm okay if you decide to write it as y to the 1/2. You can write that as y to the 3/2. That's fine with me. Okay? It doesn't matter to me. Any questions? That's as hard as it gets, is right there. Awesome.